we're treating circle theorem. That was what we're treating. Then we have to talk about the part of a circle first before we proceed. Now, as it is currently now, look at what we have. Now, I place this here. Now, this is a chord. We said the chord is a line that divides a circle into two, not into two equal parts, but into two. So that's what we have here. Now we have this line. This line is a diameter. This is the center of the circle. If this is the center of the circle, then this line is a diameter because it is cutting across the center of the circle from one part of the circumference, then cutting across the center of the circle to another part on the circumference. So this line is a what? A diameter. Now this is the center of the circle again. Then any line drawn from the center of the circle to any point on the circumference, then this is what? A radius. Are you with me now? So let me just indicate it so you get to see. So that's the radius. That's the radius. So this is a radius. This is another radius drawn from the center of the circle to another point on the circumference. In short, this is another radius, center of the circle to another point on the circumference. So all right. This is another radius, and this is another radius. So I believe you understand better now. There's another radius. Now this is a chord. Why this long line here is a diameter? Okay. So now that's a part of a circle. Then the distance round, if I move around this circle now, the distance round this line, the distance around the circle is called what? Circumference. So in four-sided or three-sided shapes that is not curved like this, like a round shape, we call it perimeter, but in a circle it is called the circumference. Now look at this part in a circle also. So this is bounded by two radii, because that's the plural of radius is radii. So bounded by two radii and what? An arc. So now I can decide to pick any point. Now from here to here, now on this circumference is an arc. Even from this point to this point, the distance here is what? An arc. So any 2 points on the circumference will give you what? An arc. This is an arc. Okay. Now definitely this is a point. Is another point. So if I move around from here to this point, so I have an arc. Now this is a sector. A sector is bounded. That was what I drew here. The radius, this is the center point, then the arc of the circle. Okay. Now this is a sector. So definitely it has an angle where the two radius meet. Can you see? That is an angle. So that is an angle. Okay. So that's the radius for you. So that's a part of a circle. Are you with me now? Then we are talking about the space segment. Now if I draw this line chord, you see we have a small part of a circle here and the bigger part of a circle here. So this small part is called what? Segment. That's what we call the segment. Okay, call it segment. So what kind of segment do we have there? So these are that's the major the minor segment. That's the smaller part, the minor segment. So why the bigger part is called this other part, from this line, the other part here, the whole part here is called the major segment. Major segment. That's the major segment, as you can see. So that's just the part of a circle. So now from there we now move to the theorem itself. Now the theorem, you can see from here the theorem 1. So I guess when I was recording the first video, that was when I was doing all this. So it was live when I was doing all this. So I guess the record was not saved. The recorded video was not saved. I don't know what happened. I think I had issue with my software. You understand? So but I need to check if it is still recording because I just don't know what happened. Alright, let's proceed. Now the theorem 1 says the line that joins the center of a circle to the midpoint of a chord is perpendicular to the chord. The line that joins the center of a circle, the center of a circle, this line from the center of the circle to the midpoint of a chord. Now AB is a chord, as you can see. Line AB is a chord. Now this line drawn from the center of a circle coming to the midpoint of this chord will form what we call a perpendicular line. So we have AB here. AB is the chord, which is equal to, look at, AF plus what? FB. That's the chord. While OF is a line drawn from the center of the circle. So now this is meeting this chord at the center. So that shows that AB is perpendicular to what? OF. That's what we have here. AB, line AB, perpendicular to line OF. I guess I need to draw this so you get to know it. That's line OF. Are you with me now? Now let's proceed. So that is what we have here. You can see that's what we have. This is AB. AB. This is OF. OF. So this is what we call perpendicular line. So a line is said to be perpendicular if their point of intersection is giving us 90 degrees. This thing means 90 degrees. Now let's proceed. Now the second theorem says equal chords of a circle are equidistant from the center. Now if these chords are the same, their distance to the center of a circle are also going to be the same. So you can see the way we draw this. Now I have to go to the other one here, to give you another, pattern of drawing. So you see that it is still the same. Are you with me now? So we have AB here. This line AB called AB, then we have called CD. If I draw a line to this center of the circle, this point O, the center of the circle, if so far this BA is equal to what? CD. Just like this, when AB is equal to what? CD. When these lines are giving you the same measurement, definitely, if you draw a line to the center of the circle, it must be the same, equidistant, the same from the center of the circle. Are you with me? It doesn't matter the placement of any of the chords inside the circle. All these things can be proven if you draw them on a plain sheet, so you don't need to stress it. Just have two chords inside the circle of the same length, draw them anyhow inside the circle, and measure the distance from the center to any point on the chord. You get to see that the lines are giving you the same length. Now let's move to theorem 3. Now the angle subtended by an arc or chord at the center of the circle is twice the one subtended at any point on the circumference. Yes, I have to use arc or chord because line AB here forms an arc, and also line AB forms a chord. So any of these two, either chord or arc. Now look at this line. Look at this line forms this angle. Look at this angle. This same source AB again forms. Forms this also. Can you see? So all these will give you the same thing. Now look at the one at the center, AOB. This is the angle at the center. Now if the angle at the center here is 130, any angle formed on the circumference coming from the same source, which is the chord or the what? Arc, must be divided into two. So it shows that the angle at the center is twice the one you have on the point of the circumference. So that was why we have to divide angle COD here, COD by 2, to give us angle what? CXD, which is angle X. Are you with me now? So if angle COD is this, in short, let me put CX here. Angle CXD. I have to increase it. Alright, so I'll be having this here. So this angle CXD, I have to put the angle here. In short, let me clean this and draw a bigger one. Let me use this. Alright. So let's proceed. So do you understand that now? This is angle CXD. CXD. Now the one at the center must be twice the one on the point on the circumference. Are you with me now? Let's proceed. Now theorem 4. Now the angle in a semicircle is a right angle. Is a right angle triangle, not angel. Right angle triangle. Now line AB cutting across the center of the circle is what? A diameter. Any angle we have subtended by this line on the point of the circumference is angle 90, because this is the angle we have in the semicircle. Are you with me now? So I guess I did another one here. Let me do that again. Now let me drag this here. So I'll be drawing this semicircle. Now let's say you have a diameter here. I purposely have 3 here. These 3 I have here. I have 2. Let me just separate one. So let's say this is 1. This is another one. This is I'm only showing you also how we can have them in a circle. It doesn't matter. Let me have this. It's still angle 90 from that point. Still angle 90. Are you with me? I can have another one here. Let me drag this here so you get to see what I'm talking about. So this is a diameter. Then look at this. So it doesn't change anything. Still the same thing. That's angle 90. Okay. Doesn't change anything. So that's angle 90. Can you see? So the angle here is angle 90. Now let's move to the next one, which is theorem 5. Now what theorem 5 is saying is angle in the same segment are equal. Now look at this line called AB. I've divided this circle into 2 sections, which is the minor segment and the major segment. So angle AB, as you can see, line AB, which is the chord, or line AB, which is also an arc like this, is suspending this. So now all these angles here are in the same segment. So if this is 60 degrees, then this will also be 60 degrees. This will also be what? 60 degrees. So far they are in the same segment. Now this is going to be the part 1 of the video. I'll be recording the part 2 of the video. We'll be solving some series of questions and concluding the part with the remaining 4 theorems. So are you with me? So thanks for watching one more time. So we'll see you in the other part.